So hello everyone and welcome for joining this webinar. Today we are talking about serverless, the RADON project, and Ethicode's contribution to it. This is the first out of two webinars about the topic. Next webinar we'll have more detailed demos of the RADON framework. With us online, we have Sami representing Ethicode and Giuliano from Imperial College London. And my name is Hans. This is what we will cover today. I will start this webinar by introducing both serverless and RADON before Sami will give a concrete use case on how to utilize the benefits of serverless. His example will be based on the test automation tool RADON Framework. Giuliano will then, the project lead and coordinator of RADON, will follow up with an introduction to the RADON framework. Before I will end this talk with Ethicode's role in this project. So serverless, I'm not going to define it here because I'm sure there are 20 different definitions of it in this call only, and perhaps none of them are wrong. What we do know is that with the emergence of cloud computing, serverless technology has increased in popularity. In a recent survey among developers, 40% said that the serverless played an important role in their IT system. Although the increased hype, the curve has now flattened, and the amount of companies planning to adopt serverless has gone down from 19 to 16%. And the graph on the right shows us two things. One is that serverless is, people care less about serverless during Christmas. You see this dumps every December. And also you can see that the interest generally has flattened out. There are some well-known reasons behind this stagnation of serverless. One is transition cost. Restructuring the application to fit serverless takes both time and money. And vendor lock-in. Your infrastructure will be locked to a cloud-specific resource, and often the source code in itself will be entangled with cloud-specific SDKs. You also have limited languages and development framework to work with. And with RADON, we want to address some of these concerns. However, the one thing serverless is suited for are specific, short-lived, event-driven functionality. And in the upcoming talk, Sami will present such a use case. The RADON framework. Giuliano will cover the functionality to a greater extent, but I want to highlight a few things. The RADON project is a research cross-industrial academic project, including 8 partners from 8 different countries across Europe. Our ambition is to create an end-to-end framework that covers all steps from development, testing, orchestration, and monitoring of serverless architecture and applications. It combines existing open source technologies with in-house built tooling and wrapping around the components for a seamless interaction. And after this introduction of the topics, I'll give the word to Sami and the RADON framework. The floor is yours.
Thank you, Hans, and welcome everyone to this short presentation. I hope you can see my screen now. Yes, so today's short presentation is going to talk about how we can utilize serverless computing for executing automated tests. And for that, we will use the RADON Framework as an automated testing framework, and also Google App Engine as the serverless computing provider. And we will show that it's actually possible to achieve similar setup in other cloud providers as well. My name is Sami Al-Ajami. I'm the technical director of Efficode Norway. But let me start with an early disclaimer that this presentation was initially made by my colleague, Juho Saranen, who unfortunately couldn't deliver it today, so I'm just replacing him for today. So the agenda that we have for this presentation is that we will start shortly with providing an overview of what RADON Framework is and what are the main features of it. Then we will describe a solution or a setup where we can use Google App Engine to run or execute RADON Framework tests, and we will demo that as well. And finally, we have a slide on explaining how we can achieve the same setup in other public clouds. And we close with questions if there will be any. Yeah, so what is RADON Framework? RADON Framework is an open source automated testing framework that was made by Nokia Networks, I think in 2008. And since then, it has been used by a lot of industries and companies, and it has built its own active development community. Currently, it's backed by a foundation that has around 40 member companies that support it. The main feature of RADON Framework is that it allows you to define your test suite specifications in a human-readable format that is based on keywords. And we will see a simple example when we get to the demo. Another advantage or feature of the RADON Framework is that it's extensible by libraries. So it allows you to use your own or build your own libraries using a few supported languages, or use someone else's open libraries that they have made available. A typical example of libraries is, for example, the Selenium library, which allows you to do UI testing on your application that you are testing, or also DB library, which allows you to do tests on databases. Another advantage is that it has built-in support for remote libraries, where you can execute your tests on a remote location simply by making a request over the network. And we will utilize that in our setup as well. So let's have a look at the solution or the architecture of the solution that we use in Google Cloud to achieve that kind of serverless test automation. In Google Cloud, we use a few services to achieve that. So the main thing is, of course, Google App Engine, which allows us to run containers, to run our applications in containers without having to worry about the underlying infrastructure. So it basically doesn't require us to set up any servers or watch for them or update them and maintain them. It also takes care of scaling the application based on the incoming demand on that application. And also you get a pay-as-you-go model, so you only pay per the number of requests you are getting. Another service that we use from Google Cloud is Cloud Tasks, and that provides asynchronous task execution by simply decoupling the different components in the architecture and allowing them to interact in an asynchronous way. The Cloud Data Store is a NoSQL database, which we use for our RADON Framework server application to store things like the the records of the tests that have been executed, their logs, their metrics, and so on and so forth. And finally, the cloud storage service allows us to store files for the test reports and the test logs in the cloud. So if we zoom a little bit more into the architecture of this solution, it all starts on the left with the Robot Framework server, which is running as an App Engine instance. And you will see that there are a few other App Engine instances in the architecture. All of them currently are actually a single instance that has multiple modules, but in practice, you could split them up into an instance for each of these. So the Robot Framework server loads the test suites that are available from cloud storage, because these are just files, Robot Framework files. And then it has access to a database where it stores information, as I mentioned, about the records of execution, the logs, the locations of the logs of previous executions, and so on. And on the UI here, you can choose which test suite you want to use, and you can provide some parameters for it. Once you trigger an execution of a test suite, what will happen is that this execution is queued in the Cloud Tasks queue. Then it's picked up by the Robot Framework execution, which is again another serverless container executing the Robot Framework tests. As part of this execution, it can use or utilize remote libraries, which are also running in a serverless way. And then when it finishes executing your tests, it will generate reports, metrics, and also logs. And the logs go directly to the cloud storage for storing them. But the reports and the metrics are going to be processed an extra step before they get persisted in cloud storage. And that step is simply updating the database, the cloud's data store database, with links to those reports and metrics. So it's a pretty simple setup that allows us to have a fully serverless and zero maintenance test automation suite. So if we talk a bit about that solution that we have made in this demo, and when I'm talking about the solution, I'm referring to this Robot Framework server and execution and the remote library. It's basically built as a Flask app builder or using Flask app builder. And because Flask didn't have support to using data stores, it uses SQLite for the purposes of this demo. It's built as multi-module application, so all of these components that you saw running in Google App Engine, they are simply modules within the same application. The reason for doing that is that it's only used for this demo, so we didn't want to overspend or waste resources in the cloud. But in practice, when you have a production setup, you may deploy it or split it into separate applications and deploy it into multiple instances. One limitation about Google App Engine is that, and it's quite general limitation into serverless really, which is that you don't have persistent storage. So for that reason, Google App Engine allows you to write only on /temp in your application containers. And everything else is just available as read-only. At least that was the case when this demo was made. AWS Lambdas are either supporting already persistent volumes or are going to support it. So this is, of course, changing over time. There is also another limitation about the duration of execution. So the default option when you set up Google App Engine is that you'll get automatic scaling. And that allows you to have up to 10 minutes HTTP calls. So if your tests requires more than that to run, then you may need to use the either basic or manual scaling options. With that, of course, there will be an extra cost. So yeah, just keep that in mind. So it's time to have an actual look on the solution that we have built and the demo that we prepared. So here you can see the application itself, and you can access it yourself on this link, robocon2020.appspot.com/robot. And the basic interface here is showing us, this is basically the Robot Framework server that we deployed, and it's running in Google App Engine. And it has, or it shows us on this page, the history of all previous test executions. So if we click on one of those executions, the first time you interact with this application, it might take a few seconds to load because of the cold startup time for serverless applications. So when we check one of the tests that we have executed, it shows a visual representation of the test suite and the test cases that have been executed. We can also see the report, and you can see that the report is actually stored in Google Cloud Storage. And that report is basically a Robot Framework report that gets generated after executing the test. We can also see the logs of the tests that we have executed. Now, if we want to run a test, we would go to /run, and we get this simple interface where we can choose what test suite we want to run. Those test suites are stored in Google Cloud Storage, as I mentioned before. And they are basically Robot Framework test files and configurations. And we can also have arguments. Let's call it test1. Test2. We can run the test suite and start the run. Because this is set up to work in an asynchronous way, the results will not come back immediately. So what happens now is that it has been put into the cloud task and it gets processed in all of those steps that we showed in the architecture. Once the results are available, which in our case will be available almost instantly because it's a very simple test, we can see the results becoming available in this link. Again, it's just a visual representation of the test suite and the test cases that we have executed. And if we go back to the home page, we will be able to see, this is the last execution that we have executed. We can see the metrics, for example. And that's again a Robot Framework generated metrics page. And it shows us that there were 2 test suites and a total of 5 tests, 4 passed, 1 failed, and so on and so forth. So that's basically how we can execute and run tests using serverless frameworks. Now to look at the tests themselves, the source code, by the way, of this demo is all available open source on GitHub. So a particular test file that's written in the Robot Framework format will look like this. It's quite human readable. So these are the arguments that we pass, and then we can log stuff here and so on and so forth. We can look at the other tests as well. So we can see that the first case is doing a simple log. Second case is logging and then failing deliberately. So yes, this way we can run and execute automated tests using Robot Framework on serverless infrastructure. Now in our demo, we have used Google Cloud, but it's actually possible to use other cloud providers to build a similar setup. So in Google Cloud, we used App Engine for serverless compute. We used Data Store as a NoSQL database and Cloud Storage for blob stores, and Cloud Tasks as a tasks queue. If you want to use AWS, you can use AWS Elastic Container Service for running your your containers without worrying about the underlying infrastructure. You can also have DynamoDB for NoSQL databases. You can have S3 for blob storage. And also you can use simple queue service for task queuing. In Azure, if you want to use Azure, you can use Azure App Service for the compute, serverless compute. And you can use table storage for NoSQL databases and Azure Storage for blob storage and Azure Storage Queues as task queues. So in summary, we were able to run robot framework tests remotely and even the local libraries as well on serverless compute resources. That takes away all the maintenance burden from us and simplifies the setup and the maintenance of this testing setup or architecture. Finally, the source code of this demo and presentation is available, again, open source on GitHub. And that concludes my presentation. Now it's time for questions, if you have any.
Do you have any examples of more advanced test cases?
Not in this presentation, but basically you can execute any robot framework test cases that you can build yourself with the restriction of the execution time being limited to 10 minutes. But again, you can even work with that if you upgrade your or change your scaling setup in Google App Engine. The kind of tests is basically whatever you test or you can test in Robot Framework. So a more complicated test case would be, for example, if you have a web application, you can instruct your test suite to exercise the login feature by going to a website and logging and expecting certain results and so on. And if you look at the Robot Framework website, there are a few examples that shows you what you can achieve with the Robot Framework.
Thanks.
Welcome.
If that was it, I suggest we continue with Giuliano.
Hi, everyone. Okay, so good afternoon, everyone. My name is Giuliano Casella. I'm an academic at Imperial College London, and I thank Ethicode for hosting my presentation. I'm going to discuss with you the RADON Framework, which is an open source solution to help the engineering of microservices and serverless-based applications. So this is a European Commission-funded project. This is the collaboration of academic and industrial institutions. We are 8 organizations in total across Europe that are working together for a period of 30 months to build a new framework in the open source space to help the software engineering of serverless-based applications. This project consists of around 30 people, and currently we are nearing the end of the project, and so I'm going to present the overall idea and architecture of our framework. If you want to discover more, I will give you at the end of my talk some pointers to find more information. You're, of course, all very familiar with serverless computing, and in particular, function as a service has changed the way and the simplicity of building applications in the cloud. And there are, of course, many advantages. The provider can scale for you the functions. You can save on cost when you have event-driven workloads. There is, of course, a strong synergy with microservices-based architecture. It's easy to include serverless functions in the design of your microservices-based system. But there are also some elements that make this a complex design space. For example, when you play with serverless functions, there are stateless functions. And this means that their state needs to be persisted somewhere else, on storage, and they can be affected by events that are triggered either from the environment in which your software operates or from other resources in the cloud. And so the design of these software architectures is complex because it's a very rich space of events and resources. And there are many questions that come up when you think to build an application that is scalable, efficient, reliable, and complex. For example, you might wonder how you can build these applications using DevOps methods in a way that avoids the vendor lock-in. And so you might want to have some portions of your applications that run with a certain cloud provider, others that run with another cloud provider. And so depending on the constraints you have, it might be easier or more challenging to build these architectures in a way that is extensible. If a new customer comes in, you want to be able to perhaps add certain services in the same cloud domain where the data of your customer is. And so it's important to keep in mind that the vendor you choose might not be the one you will use in the future. And so how do we get there? Also, when it comes to quality of service, performance, reliability, security, etc., you have, of course, a very challenging domain there because it's difficult to ensure at the same time all these properties. And so if you ask the question, what is the best way of configuring my application? How should I set the configuration parameters for the various services that I use in my application is a difficult question. When we look at deploying in the cloud, quite often now there are techniques based on declarative models that allow you to explicit the architecture of your system, declare the resources that define your architecture, and then your architecture is automatically instantiated in the cloud. But as you make these specifications, how do you debug these specifications? And then when the application is running, how you test it and monitor the outcomes of your test. Now, if you think to this question in the context of a system that operates across multiple clouds, of course, it becomes a very challenging and demanding space that our project tries to tackle with several innovations. And so RADON is an open source framework whose main value is to offer a DevOps toolchain to build function as a service based products, avoiding code and data lock-in. And in particular, there are three main characteristics of this framework that you might find interesting. First of all, there is a high degree of automation based on DevOps in this framework that reduces the time that it takes to someone like a developer or a member of our organization who wants to adopt serverless plus to come up with early prototypes and convince management that that's a technology you want to use in your company. So the learning curve is reduced by means of automation, and as we will see in the next few slides, also by the use of graphical models. Secondly, RADON, compared to other frameworks to build solutions in the fast space, allows to incur low cost and low risk in building software products, because our platform allows to build the serverless fast in multi-cloud domain. And also there is native support for migrating and synchronizing data between clouds. Furthermore, we have tested that is the possibility of checking the performance and quality of service of different vendors, and therefore you will be able with RADON to run several tests comparing the cost of your different implementations and decide what vendor to adopt, or anyway giving you enough information to understand how to later evolve your application if you decide to migrate it from one cloud to another cloud. And lastly, a very important contribution of our framework is that it allows to reduce the cost to build solutions for different business use case compared to the one you envisioned at the beginning when you created the software, because we use a model-based framework inside RADON. We have extended the standard model called Oasis Tosca models that facilitate reuse and customization of architectural elements for your application in a way that is loosely dependent and depending on the particular nodes you consider, possibly also entirely abstract compared to the hardware and the target platform for your system. And so you specify these high-level models, you supply them to an orchestrator, and this orchestrator will deploy them and run Ansible code that we bind to these modeling abstractions to help you with the deployment and automated configuration of the topology of your system. And so, as I said, this is a DevOps approach. And so our DevOps consists essentially of three main phases: graphical modeling, where you design the topology of your application. Then you have a model-based delivery, whereby this model is supplied to the orchestrator and instantiated in the cloud automatically, together with support services like monitoring. And then there are quality engineering tools that help you understanding how to progressively improve the quality of your application, for example, through performance testing. If we look at a finer resolution on the contributions of our framework, which is available on GitHub, and therefore you can easily access all the tools shown in this slide. We have two main parts. On the one hand, that you see here on the left, there is the RADON IDE, the design and coding space for your application, that consists in a set of tools to model graphically the application architecture, to decompose an existing monolith into a microservices-based architecture, and to carry out quality assurance assessment, looking for bugs in your infrastructure as code models, or verifying requirements that you have annotated on our graphical models by means of a specialized language that we call constraint definition language, or run your test through a continuous testing tool. In terms of the runtime support, once you have specified the application architecture, you will send it to an orchestrator, which can also take care of setting up data flows, possibly passing through functions that process this data and possibly transform it. And this is all integrated through CI/CD with the environment of the IDE. And we also supply a function hub where you can store and reuse functions, a monitoring system that will be automatically deployed alongside your application, and a so-called template library that provides a number of templates and blueprints that you can use to be able to instantiate your application over different target clouds. So you have reusable abstractions and supporting code to create functions on Azure, on AWS, on OpenFaaS, the open source on-premise environment, and on Google Cloud Platform. This is a look and feel of our IDE. Is an extension of the Eclipse Che project, and you will find a RADON workspace in it. Once you open this workspace, you will have access to the various components of the RADON environment, our plugins, and menu extensions that allow to run particular functions of the framework, for example, on the models. This is an example of the look and feel of our system. And so here is the graphical look of the models. This is, for example, a pipeline that brings data from a S3 bucket into serverless functions. And here you can see a more complex topology. As you scale up in complexity with your application, you can graphically draw and configure every element in this diagram, which represents a function, and come up with a deployable architecture that with one click you can find already deployed in the cloud after the orchestrator completes its execution. When we look at these models, behind the models, there is a textual description of the architecture of your system, where you can manually customize, for example, the memory you assign to the functions or other characteristics like binding to software archive. And so overall, the way this framework works is that you're going to draw the model, you're going to pass it to the Xopera orchestrator, and this will deploy on the cloud alongside the configuring data pipelines to move the data through your business logic implemented in the functions. And continuously, we will monitor the application state so that you can see it while running. We also offer a number of quality assurance tools, which I already mentioned, to analyze the correctness of the requirements, the correctness of the infrastructure as a code, and test the quality of service characteristics for your implemented application. You will find on GitHub at the URL you see on the left, over 50 repositories with the open source code for the different modules that compose the framework. If you click on RADON methodology, you will get a detailed description of the framework, as well as a link to request test access to our public instance. And we have also a website with YouTube videos that will show the execution of the tools that I've illustrated in the previous slides. And before I conclude, I want to show you just briefly a minute of the graphical tool I demonstrated. So I'm gonna play just for a minute this video that is one of those that we offer in the cloud. So this is the environment where you can draw. This is an example of an application that takes images and resizes them using AWS. And through this environment, you can annotate the properties and the requirements associated to the different nodes of this topology. And subsequently, you will be able, from the main IDE environment, to launch the application and deploy it. So you will find these and other videos on our website. And this concludes my presentation. I'm happy to take questions. Thank you very much. Is there any question?
I think you were perfectly clear about your message, Giuliano.
Thank you, Hans. Thank you.
Obviously.
Okay, so in this case, I hand over back to you, Hans. Thank you very much.
Thank you for sharing. Just before we wrap up, I want to highlight some of our contribution to this project. Each partner in the consortium has concrete areas of contribution, and we will get, in the next webinar, we will have more specific about each tool and the functionality. I just want to highlight some of our objectives. The first one, we strive to provide an industrial perspective to the project. This is based on own experience with cloud and infrastructure as code and interaction with customers. This input is translated into concrete system requirements for the framework. The role of Function Hub is to create a repository of reusable public functions as a service. Oh, sorry. In the RADON framework, when creating an Azure cloud function or a Lambda, instead of selecting a local zip, you reference the function from a file from Function Hub. And this file will be available through CloudStash, which is the domain of Function Hub. We are also responsible for the CI/CD functionality of the framework. This means we are making sure all tools can be included in a CI/CD pipeline. And we are also providing templates and documentation for user to get started with the CI/CD. The framework has not officially been launched yet, and we are currently working on the branding aspect of the product. The final contribution to the project is validating the framework through a self-defined use case. And our use case is an artifact manager fully built on serverless technologies. Both functions as a service for the artifact interaction and handling repositories and users, and backend as a service for storing the actual files. And the model that Giuliano showed previously is this is the model of the serverless artifact manager. And it contains a host of the cloud and an API gateway that is linked to different functions. And the different functions is linked to table storage for user repositories, and in addition to file storage for the artifacts. Missing features for the next period would be a node for Route 53 that handles DNS. More detailed demonstrations of how we develop this will be presented in the next webinar. And I hope to see you all there. And I think we can take all questions here. There was a question from the Q&A. Where can I find this? Yeah. Do you want to take this, Sami? Or is it answered? Or you want to just do
yeah, I can just reiterate the answer. The question was about what amount of tests would make serverless automated testing economically sensible. And it really doesn't matter how much tests you have. It's more about how much infrastructure costs you can save. So if you have reserved some VMs that you are using only for running your tests on, and if your tests are compatible with the limitations of serverless execution, and you don't require like special hardware or something like that serverless providers cannot offer you, then moving or running them on serverless will automatically incur saving into the cost of those VMs that you have laying around and you have to keep maintaining them. This can apply or is applicable if you have 2 or 3 servers, for instance, because then your serverless cost will be pretty minimal and even could be falling within the free tier of several cloud providers. But if you have a lot of load, then of course that means that you will save a lot of virtual machines costs, and you will still be paying something for the serverless, but it will be much cheaper than the cost of owning and maintaining virtual machines, either on bare metal or in the cloud.
Yeah, and maybe also mention that cold startups is okay, and often tests is not really like speed sensitive. From a user's perspective, you don't care about how fast your test is executed. From an end user perspective. So, yeah.
Yeah, the execution speed is, of course, it has its importance, but the cold startups most likely will not be adding too much delays, unless if you are pulling large amounts of data or doing something like that on the startup of your application. But that brings us again to the suitability of running your tests in serverless in the first place, because not everything can be executed or brought into serverless.
Yeah. Okay, anything else? Otherwise, I thank you for participating in this webinar, and hopefully I'll see you again. The next webinar, we don't really know concretely when it's happening, but it's sometimes around January. So stay tuned, and yeah, maybe you will even have tried out the beta version of the RADON framework before the next webinar. Okay. So thank you for showing up.